Okay, this session we're going to talk about seeding, which would include RowFlow and vDrive. Many of the same concepts can be applied to either one. So we'll try to reference both. What I'm going to show you here on the demo is a vDrive setup, but to start out, let's go into our setup and systems here on the Gen 3. So we've got up to 4 rate sections available, and you can see by the color that rate section 1 is for all 24 rows. So these rate sections, rate section 1, 2, and 3 anyway, correspond to this 3 switches on your switch box. So rate section 1 would be the left switch, number 2 would be the middle, and rate section 3 would be the right switch. So you can manually shut rows off if you have these set up as such. So we're going to set this up as the right. So now you see I've got rate section 1 and rate section 2. So if I would shut the middle switch off right now, it would shut off the right half of the planner. So we can actually set up 8, 8, and 8. Let's see, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 5, 6, 7, 8. So now we got 3 sections. So now all 3 of our switches actually do something on the switch box. So this would also apply to RowFlow. However, you would have to set these up depending on your hydraulic motors. So probably 1 hydraulic motor for the whole planner, or 2 hydraulic motors, a right half, left half type of a thing. Only on really large planners do you end up putting 3 hydraulic drives on typically. But so that's how you set up rate sections. The way I use these is we plant over a handful of terraces on our different farms and over the orange risers. So we try to have a guy there on a 4-wheeler to pull the riser off so the planter doesn't have to stop. Well, when we drive over that riser hole, that section of the planter, the operator is supposed to flick that switch on and off so it leaves a 2-foot gap in the crop so that you don't smoke it with a combine when you come through there 10 o'clock at night and you can't see the orange riser very well. So that's one way that we use these different rates sections on our planner. As far as the calibration state down here, so on vDrive, it's going to be distance based, and on RowFlow controlling clutches, it will be time based. So you have to stop and yourself and read the text very carefully so you don't get confused at which way you're going, if you're going to increase or decrease the number. But if you want to make adjustments to your clutches, this is the screen you would do that in, is this calibration state. I would say for a vDrive, half of the time you don't make any changes. The other half of the time, or 25% of the time, you increase the number. You know, you need to make a positive adjustment, and the other 25% a negative adjustment. But with clutches, since clutches, different brands of clutches, their timing is all different. between the brands. So that takes a little bit longer to dial in, whereas vDrive, that timing value is already predetermined, pre-known, so it makes that process a little bit easier. The coverage pattern piece, then I would recommend for both vDrive and RowFlow at the start of the year, set it on no offset. It's a little bit easier to dig on the end rows and be able to tell if you're clutching out when it's supposed to be right on the row. So set it on no offset to start, and plant and dig. You have to dig every year. Everybody has to dig every year. You can't just say, oh, well, it was close enough last year, so this year is going to be close enough again. That may or may not be the case. So you have to dig every year, and once you're happy with, clutching out on the line, that's when you're going to come in and do your offset. If you want a half row offset, that would be a 15-inch. That's interesting. Or a custom offset is generally what I run. So I kind of enter in, 15 inches is too much for my liking, but I try to hit that 6 to 10 inch, 6 to 8 inch, somewhere in there. So it shuts off that row 6 to 8 inches before the end row. And when you hit custom offset, it wants to know what percentage of rows. It's not distance or anything, or time or anything like that. So like a tenth of a row, a 30-inch row would be 3 inches. So if you enter in 3/10, that would be 9 inches that you're going to shoot for offsetting from the end row. And the simulator's acting very goofy right now, so sorry for that, but we'll hit back. And that logic applies exactly the same for RowFlow as well, as far as that coverage pattern goes. For vDrive, there is no run cal. Like I said earlier, the timing is already predetermined. It's never going to change. When the SRM sends the signal to the vDrive to start or to stop seeding, Precision already knows how long that's going to take to travel down the wire, and for it to stop or start seeding, it's all predetermined. So there's no clutch timing for vDrive, whereas with RowFlow there is. So depending on the clutch manufacturer, some clutches have more of a delay than others. So there is some differences there. So depending on the clutch, like some of the older True Counts only had 6 cogs in the stop mechanism, so the clutch could potentially allow the meter to spin 1/6 of an additional revolution before it would clutch off. So that could be 3 or 4 seeds pretty easily. So there are some variations between other clutches. Just depends on the brand, etc., that you're running. So let's go back to the home screen and see if I can configure the vDrive quick start button. Here it is. There's the small one, and here's a larger one. So I'm going to click that guy, and let's say we're not running smart firmware, so I don't care about that metric. I'm going to stick him there and hit the check mark. So it's this button allows you to try to eliminate the gap in the crop when you start from a standstill. So if you stop in the middle of the field or you back into a corner and sit down, sit the planter down, it's going to take about 24 inches. There will always be a gap, some gap, because of the time it takes for the seed to fall from the meter to the ground. So this little feature here is to try to eliminate that or minimize that. So when you tap it here, you get a 2-second countdown, and now those, when vDrive, when you're using vDrive, as soon as it says active there like it did, those meters are spinning 3 miles an hour for 7 seconds. So if you don't move the planter, you're going to have a little pile of seed under each meter. As soon as it sees registered speed, that takes over. But it's simulated at the very start, 3 miles an hour until it sees speed. So that's the way this one works. 2, 1, and then you'd be letting off the clutch and taking off at that point. There is the same thing for RowFlow. If you've got hydraulic drives, it acts a little bit different. It will not automatically start the motors. What it does on the RowFlow one is it just makes the whole system really sensitive, extra sensitive to change in motion. So it kind of puts the system on a heightened alert, so to speak. So it's extra sensitive to motion. So when you let out on the clutch, it senses that earlier and can spin the motors quicker to minimize that gap in the crop. So the vDrive one will actually spin the motors even if you don't move, whereas the RowFlow one will not do that. It's just kind of on steroids, ready to go a little bit quicker than it normally would be. So let's go to the equipment and these planter measurements and tractor measurements. I want to talk about nav controller specifically on Trimble systems. So these measurements and the GPS offset check on mapping and clutch timings, etc. The GPS offset check is designed to make sure that the measurements we enter in there on our tractor and planter jive with the measurements that the GPS measures it to be. So once you perform this and it checks out, then you can trust your map, meaning that you can, if there's a gap in the map, there's a gap in the field. If there's an overlap on the map, there's an overlap in the field. So this GPS offset check makes so that you can trust that. And it should be done every year, even if it's the same tractor, same planter, same GPS globe, same everything. I recommend that you do this every year. If hopefully there's no change and it will just be a once and done, but it's a good safety check in case there is measurements you have to tweak or whatever. So I'll walk through. So let's say we entered in our tractor and planter measurements already, with a tape measure. And now we're going to do a GPS offset. So I'll just walk through this. You set your flags on the ends of your planter at the seed exit, which is basically the gauge wheel center. And then hit continue and you go make a loop. You can either drive one continuous loop, or if you're in your driveway or side yard or whatever, you can back up and drive forward and back up and drive forward, as many times as you need to get lined up. And then when you're driving back the other way, go ahead and click this button another time, and stop when the planter is between the flags, the gauge wheels again, but your tractor's facing the other direction. And then hit continue, and you'll get this screen. Same on a Gen 2, you'll get a screen similar to this. And what we're interested in is this box here, the difference. And since we're on a simulator and didn't move, you know, we're at negative thousands of inches. Well, I like to see this number 4 inches or less, then I'm happy. If it's more than 4 inches, I usually change the C measurement on the tractor. I've just always done that and had good success with the modeling and the drafting of the implement still, even if you have to adjust that quite a ways. It seems to work well. So adjust the C measurement, either plus or minus. So in this exact case, we're negative 1,007. We would need to add 1,007 to the C measurement, and then redo another check to make sure that we are we're 4 inch or less value there, and then we're good to go. This one up here is how offline of center you are, and since if you were snapped on an AB line, I guess it would mean a little more, but since you're just jockeying around in a yard and driving freehanding it, if you're off 8-10 inches, I don't even hardly care, because you might not be square with those flags perfectly. So that's the GPS offset check. And I will also comment that nav controllers, most of the time, not always, but most of the time, export GPS out of the rear axle or over the rear axle. So your C measurement commonly is 0 because the globe location is over the rear axle in a nav setup. So be aware of that. That's different than the other GPS systems out there. Can be a little tricky. A GPS offset check will catch it, but generally I set that C measurement to 0 if there's a nav involved. Let's jump to, I want to show the diagnose page here, diagnose vDrive, and this applies also to RowFlow. So if you're questioning the accuracy or the 2020 itself, maybe is it commanding the right thing? Is it actually planting the right thing? You can tell quite a bit of information from the diagnose seating screen. So here, in the vDrive case, we have a commanded RPM and actual RPM. And on a RowFlow setup for hydraulic drives, you'd have the same thing. You'd have a commanded RPM and an actual RPM. So and a commanded population and an actual population, you can see we're commanding 32,000, but we're actually dropping 36. So that's a problem. But on the other hand, we're commanding, our commanded RPM is pretty much the same as our actual. So this would indicate to me that there's some sort of a setup issue, because the motor is spinning what it's being commanded to do, but the wrong amount of seeds are coming past the seed tube sensor. So again, this is a simulator, so you got to take everything with a grain of salt. But you can definitely glean information from here to try to help clue you in down to supply volts, and you've got PSI pressure on the RowFlow one that you can help diagnose if you've got the right hydraulic pressure to your motors, etc. So I just wanted to kind of reinforce and clue you into the diagnose page on these drive systems to make you aware of that. One other thing I'll mention with hydraulics, as it pertains to hydraulic drives, is just because you have pressure, hydraulic pressure, doesn't necessarily mean you have oil flow. So I've seen, in fact, it just happened last week, a grower had hydraulic pressure, but his return tip, where his hose was plugged into the tractor, his return tip was blocked or partially blocked. And I don't know why that happens, but if it's because the lever gets pushed the wrong way, you know, momentarily first, or why the return tip can kind of get stuck that way. But in his case, all he had to do was reverse the flow with his lever in the cab for 1 second, and then go back the other way with the lever, and away it went. So I've seen that on Delta Force, I've seen it on hydraulic drives, and I've seen it on hydraulic fertilizer pumps. Anything hydraulic that that return line can get blocked or partially blocked, which doesn't give you the flow that you need in the circuit. Even though the sensor sees pressure, doesn't necessarily mean you have flow. So just a little tip to try to rock that switch back and forth if you if something's acting goofy. I've definitely seen that multiple times over multiple years. One other thing I'll show on this diagnose screen is this forward acceleration box here, and this is also shows on the RowFlow one. So if your drives are, whether it's vDrive or RowFlow, are behaving erratically, or it's not making a lot of sense on the control, it's kind of wild control. This is one box you can look at. So forward acceleration would mean when you are accelerating or you let off the clutch of your tractor, this should be a positive number. And when you're in reverse and let off the clutch of the tractor, this should be a negative number. So if those are flip-flopped, that would cause the system to think you're in forward when you're in reverse, and you're in reverse when you're in forward. And usually it can figure itself out, but it delays that. So that can cause your erratic behavior around your drive system. So that's just something to glance at if you're on the diagnose page, just to double check that your accelerometers are configured right, that forward is forward and backwards is backwards, because that will play some tricks occasionally. One final thing I will throw out there, this is a little bit off target, but it does have to do, or off subject from what we've been talking about, but it does have to do with seeding, is a 90 cell ESET disc. I know there's a guy on Ag Talk selling those. I think they're $90 or $95 a row. And this would, a 90 cell ESET disc would be capable of planting soybeans in 30-inch rows with an ESET up to a certain 130 or something thousand population. So as the populations get reduced in soybeans, you know, this is becoming a more viable option for better seed drop and more consistent seed drop in a 30-inch row, this 90 cell disc. What you could do, which would be cheaper, would be to buy a canola disc, which is also a 90 cell, and drill the holes out yourself. And for $55, you could have the same thing instead of 90. And you're just drilling, enlarging the holes that are already there. So just throwing that out if anybody is considering trying to improve their soybean performance, that 90 cell disc might be something to look at if you're running ESETs on 30-inch rows. Okay, I think that completes the seating session.